Thanks, Anisha. Hey everyone. Just a shout out to Anish and Prejaj. Really loved the sessions and the topics they spoke about. It was really insightful for you, even me. So, yeah, before we start, just wanted to know the audience a little bit. So, can you guys tell how whether you guys are college students or working professionals and so on? Just wanted to know you guys. Okay. Okay. So it's pretty much a mixed audience. Great. Cool. A little bit about me. So currently, okay, I'm a graduate of CET Bhubaneswar in the year of 2022. I recently joined Newtown School as a data science manager after 1 year of a job experience at Scalar. Newton School is again a tech platform where mostly I manage a team of three or four people. Uh, we have our own AI products where we use GANs and all to create better experience for students. And yeah, pretty much that's it. So, before we start this, I just wanted to know, have you guys heard about this term Tensorboard? Like, it's mostly a college student crowd I can see. Yeah, so Tensorboard. Okay, Abhinav says he's using it. Cool. Okay, got it. So you must have definitely come across this term of Tensorboard, right? What about TensorFlow? It's a very because I guess most of you should have heard about TensorFlow, right? Since Keras is part of the TensorFlow framework. Okay. So, for even for those who have not heard about it, it's fine. As the session progresses, we'll get to know what is TensorBoard and so on. Uh, okay, cool. I'll be sharing my screen now. Just a second. Just give me 1 second. Yeah. Can everyone see my screen, the slides? Perfect. So let's start the session. Since this is the last session of the day, and I guess you guys must be already at the peak of what you can digest as a human, so it's fine. We'll go slow and we'll try to see all the terms in what can be used at TensorFlow. What is the same? Acha, before I start, just wanted to know what is ML workflow? Like, can you guys give me a simple definition as per you? What is machine learning workflow? You must have heard machine learning is a very common term, but what is this workflow thing? Okay, the process to build and deploy. Okay. Anyone else? What does one mean when he says machine learning workflow? Or any workflow in general? Like, workflow is a very common term. So, what do you mean when you say workflow? Okay. Yeah, great. Mostly, as Kumar Subham said, yeah, the steps exactly. So basically, the steps we take, the whole process of taking the data, collecting the data for a use case, business case, then clearing the data, processing the data, passing it through the machine learning model, and tuning it. So this is the whole workflow, and then again monitoring and analyzing and keeping on check so the model does not actually get obsolete. So that's the whole machine learning pipeline or the machine learning workflow. So where did tensor board come in? So at this last step, when we have already created the model and we are trying to deploy it and we are trying to tune it, in that part, TensorBoard is actually way more useful. So what is actual TensorBoard? So, as you can see, TensorBoard is a very it's TensorFlow's in-house visualization tool. So once you have created the model, you need to understand like how can we improve the model? What should we do? So like we can improve the parameter, we can clean the data more. Like where is the problem lying? If the model is giving 80% accuracy and we want it to be 95%, is the problem with the model? Like should we change the model? Should we tune the model? Is the problem with the data and so on? There are a lot of factors involved in this whole workflow. So exactly understanding what is the root cause of this, like of the bad performance of the model, we need to understand the metrics and parameters and how the model is created. So to understand that, to visually understand that, we use TensorBoard. Because seeing the numbers, like if the model is given 80% accuracy, 30% loss, or let's say RMSE score of 0.34, that doesn't actually give us an idea of what is like what are we seeing. But seeing something visually actually gives a way more clarity that how should we improve or how should we go about it. So TensorBoard actually is useful for that. It helps us to visualize the whole model because people usually say machine learning is a black box. We just give the data, we get the output, but nobody actually knows what is going on inside the model. To understand the depth of that black box, we use TensorBoard. So yeah, exactly what is TensorBoard I won't be saying. As we like during the demo session, when I actually try to build a TensorBoard, you will get to understand like how these things actually relate. Okay, so features of TensorBoard. As I said, machine learning is a very black box kind of model. To understand uh, the box, this whole thing, like what is this model? What is going on inside the model? How is the model learning? What are the things which the model is trying to like use to understand the relationship between input and output? We use that to understand that thing. We use TensorBoard. It gives us summaries, the graphs, the visualizations, and so on. It also it has a lot of features like when I show you the demo you can actually understand the number of features, the actual power of TensorBoard and how we can use it to leverage into our machine learning models. Okay. uh, Again, like I won't be keeping this session more texty. I will directly be jumping into the code because telling you guys in theory what is TensorBoard is not actually going to make much sense. So I will actually create a model in the session and integrate TensorBoard there and show you like how it's done. So yeah, uh, any host is there, Anisha or someone? Just wanted to know how can I share my tab?
Hi, Shreyanshu. You can
Yeah.
just like in the bottom bar, there would be an option to present. If you
Okay.
have done that, just do that. After that, team will add your presentation to the screen.
Okay, just a second. So I should go with sharing the whole screen, right?
Whichever is comfortable with you, sharing the whole screen or the presentation that you have made.
Okay. Okay. Perfect. Okay. Just give me 1 second. I'm sharing
Sure,
the
sure.
screen. Okay. Yeah. 1 sec. Application window. Yeah. Can you just like make it that everyone can see the collab screen?
Yeah, your collab screen is now visible to everyone. You
Perfect.
can.
Guys, wanted to ask a question here. Like, have you guys ever used Google Colab? Ever tried this platform? Okay. Google Colab or Jupyter Notebook, either of them. Just wanted to understand, like, have you ever worked in this kind of environment? Okay, so I guess most of you do know about Google Colab, right? Be it Google Colab or Jupyter Notebook, you guys definitely have worked with this kind of interface, right? Great, perfect. So, can someone tell me like what is Google Colab? Since most of you have worked with it, can you give me an idea like what is Google Colab and why it's better than Jupyter Notebook? Like both are there, both have the same kind of functionalities, Jupyter Notebook and Colab. So why do you prefer Colab, or why should we go with Colab? First on Google Cloud, yes. Yes, what I was looking for was basically this, that GPUs and TPUs part. So yes, generally not many of us have the systems to, because machine learning models require a huge amount of computation. So to be able to handle that huge amount of computation, we use some Google Colab because it has GPUs and TPUs inbuilt. It's a cloud-hosted notebook platform, like where we can actually run our models on Google's own provided GPUs. That makes it very easy for us to train our models. Cool. Let's start with it. So, Tensorboard is actually it's a browser-based EA. So when you try to, it's a complete dashboard. So rendering a dashboard on a notebook is not simple. We use when we use do it in Jupyter Notebook. It as you know, like Jupyter Notebook opens a whole browser window for you, right, to work on it. So similar to that, it again opens a port for where the Tensorboard is hosted. So if we want to use it in like Google Colab, we have to load the extension of TensorBoard. So how do we do that? Let's say we have to load the. I'll just zoom in. I guess it's not visible much. Yeah. Extension. So we will use this magic operator. We can use any kind of rendering service for Google Colab using this magic operator percentile. .txt TensorBoard. Okay. Then we'll be importing the necessary libraries. Definitely TensorFlow. Okay. Have you guys heard about MNIST data? MNIST. This data. Have you heard about it? MNIST. Just a yes, no is fine. You just need to understand like whether okay, 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 cool. Okay, most of you have heard, most of you have not. I'll just show you it in little glance. So this is basically MNIST data. It contains images of numbers and the respective labels as 1, 2, 3, 4, 5, 6, 0, 8 to 9. So it's a very classic data set which is used in deep learning frameworks to actually train a model to understand or predict numbers based on their image. It's a very useful application even in NLP and so on. So yeah, we'll be using a kind of extension of this MNIST data only called Fashion MNIST. So again, who like have you guys heard about Fashion MNIST? Also, I would prefer if you guys can actually open your Google Colabs and start coding with me. That would actually be useful. Yeah, I will just show you guys what is Fashion MNIST, so that will make much more sense. One sec. We scale the data to make it less heavy on the model, and standard like scaling the data actually has its own purpose usefulness. So yeah. Now let me actually show you what the might show. So each of these data points actually contains an image. So if you can see, what is this image? This is basically a, everyone can answer this, right? Like what is this? Yeah, Lawrence and exactly. Coursera has really good, like yeah, Lawrence has really good courses. Yeah, it's a shoe, boot, pretty much that's it. Shoe, correct. So what does fashion feminist exactly contain? Yeah, that's exactly it. It's a shoe. So as you can see, it has fashion apparel. So if I like type say to 23rd or 24th image, again that would be a, even I don't know what this is, like a code or something, I guess. Let's go with 5. So this is a jumper jacket, if you can see. The full sleeve ones. This is a t-shirt, or you can call it a shirt too. So yeah, what fashion image actually contains is basically data of different kind of fashion apparels. And since machine learning models are basically computerized models, they need to have some kind of numerical labels to understand. So for this value, the actual value of the it, the output will not be actually shirt; it will be a label. So, okay, sorry. Next test, right test. Yeah. We'll change here. Yeah. So basically, when we say extreme 0, as you saw, one wrong bracket. Yeah. Yeah, as you saw, all told, this is a shoe. So the label for shoe is 9 here. So all these labels are actually computed in this data only. So we don't need to actually manually do the label encoding for this. Cool. Okay. Now, since we already know what the data is, let's create a very simple model. Since we coding the whole model, Acha, are you guys actually coding with me? Just wanted to know. Like who all are parallelly coding with me? And like, is the session going very fast or is it fine? Okay, you are on mobile, no worries. Perfect. Since yeah, I'm just sending you since you'll be creating a model, I already have the code for this, so I'll just paste it here and create the model. I'll be sending the same on chat also, so you can like copy it from there. Keep in mind the indentation because Python is a very indentation based language. Just give me 1 second. Yeah, I'm sending this code in chat too, so you can just. Since YouTube has a character limit, so it's divided. But try to maintain the indentation when you're writing this code. Okay. Going ahead now. Since we already have created a model, now we need to understand how to integrate TensorBoard in it. TensorBoard, we already loaded TensorBoard as an extension. We now need to understand how to actually make it part of our model so that it's able to track all that's going on and how the training is going on in our model. So for that, we'll be again creating a function to train our model, and then we'll be creating a callback. So what are callbacks? When we are training a model, the model actually tries to refer to a callback to store any kind of data or try to store the data as per the required callback. So we can name it a TensorBoard callback. It will be df.keras.callbacks dot TensorBoard. In the directory for the logs, I will be providing it in, let's say, logs. The optimizer I'm using is Adam. I will tell in a while. I will show you what's the like how creating using different optimizers can give us different results and how we can actually track that even. And let's keep the histogram frequency as 1. Okay. Now let's fit the model. Again, I already have this code, so I'll just be pasting it here. The training data we're providing as X again, and the testing data as Y train. The number of epochs we will be taking, let's say 3 epochs. The validation data would be expression Y test, and the callback will be our TensorBoard callback. Now finally, we will call our train model function. Is everyone with me till now? It's a simple process. We have just created the architecture and trained the model on this, and just one parameter we have added, the callback. Yeah. Now, till now it has been not much interesting because yeah, this is mostly lines of code. But now what I'm going to show you is actually make you understand why we did all this. What is the power of actual TensorBoard? So we'll just give a directory of the logs. It's logs, and we stored it in Adam. So logs, it will actually create a different directory for. Now when we run this, give it a moment to complete the training and render the TensorBoard. Yeah. So this is your TensorBoard. We'll just convert. Are you guys fine with dark theme or do you want this to be in light theme? What do you prefer? Chat. What should we go with? Light theme or dark theme? Okay. I'm just waiting who would say light. So yes. Cool. So as you can see, the training data and testing data, it has given us 2 plots for each. So if you see the training is actually increasing, the accuracy is actually increasing from it's around 83% and it's going till 86.5% and it's still increasing. So it gives us an idea okay, we can keep on increasing the epochs and it's not saturating at a point. So this is one thing. The second thing is the loss again. It gives the idea that the loss is still decreasing. So this is the first kind of data. The scalars give us the data in a very like if you're training multiple models, it will show us multiple graphs here to give us an idea. Okay, this is training and this is testing. Now coming to what is this black box? I told you guys about what is machine learning black box, right? Like it's a model which we are giving the input, we are getting the output. We don't know what's going on inside the model. This is how TensorBoard helps us with that. So this is the whole machine learning model and the whole path it took to train itself. It looks very jargonous, but let's go on little component to understand it. So if you remember, we used sequential to create a dense model, right? So if you can see, there's a sequential tab here. If we double click on sequential, this opens up the sequential. So we are able to see each component and we're able to expand that too. So again, in sequential, we use two dense models. If I go up, you can see in sequential, we used two dense models and a flattened model. So what does flatten do? The images are 28 cross 28. It flattens the image into 1DI. And then the neural network is formed by the dense layers. So this sequential part contains these things. And if you can see, each component is like listed out here as layered or dense, dense and flatten. So again, we can go into each of these components to and understand them. So if you double click it, you can see the flatten has multiple things. It's getting constant and it's getting an iterator and it's passing it through each shape and again dividing into length layered or dense. If you click on layered or dense, you can see this is the path which layered or dense took. And again, if we click on gradient tape, okay, I guess in the dark mode it's not visible much. Let me just make it into light mode. Yeah, so you can see this is highlighted. When I click on gradient tape, what happened after the model passed into gradient tape? From there, which path it took? Where did the model go? It shows us the whole the whole schema of that. So again, we created a model, we used flatten, then we went to dense. So after this, it goes into dense. And if you can even see, like this is the tensor which is going. It's 32 cross 784, which is going into the next layer, which is the dense layer. Now, if you double click on dense, give me a second, I guess my browser, yeah. I'm zooming out a little. So yes, what happens inside the dense layer? The output is coming from flatten, it's getting multiplied, then a bias is added, and then it's being passed to the next layer. So again, you can see each component in very depth here. You can see what is happening inside MATML. You can see what functions are being called. You can see what are the calculations which is going on and so on. And similar for bias addition, like you can see which functions are called, what is the bias added, and what is the kind of, like if you see this is a scalar which is going, this is the number of parameters which are going and so on. So what does TensorBoard actually show us? This is the whole machine learning model, the three layers, the three lines of code which we wrote. This is the whole part. But how it's under the hood? What's the like? What is the connection? What are the connections going? What is the output going? The dimension, the everything, every details of that we are able to see using TensorBoard. And again, this is the optimizer we are using. So if you want to understand how the optimizer is working, you can again double click on that and it will give you the whole Adam optimizer, like what is happening inside it. So it gives like this one, three lines of code, you're able to break it down, you're able to spread it out, you're able to see each part. It's like, you take a globe, you take a map of India, and then you're able to see each country, each, each state, each city, what are the map, everything you're able to see. And that gives you really more power, you a real depth understanding of how the model is working. I guess everyone is clear till now. Guys, are you able to see my screen, right? Like how the maps are opening up when I click on these parts, and how I'm able to show you what's going on inside each hood. Because there are a lot of component machine learning. We only write two or three lines of code, but there's a lot of computation going on inside. So if you really want the full power, if you really want to leverage the full power of machine learning, you need to understand what's going on inside, how every nut, every bolt, every screw is working, and how tuning each one of them can affect a model. Cool. Perfect. And then I will just show you the histogram. So we use three epochs, right? So in each epoch, what are the distribution of the tensors? What are the distribution of the weights? The weights are basically what? they define the relationship between the input and output variables. So how the weights are distributed in each epoch, that is shown. In the zeroth epoch, the weights are distributed in this format. Like the values range from around 5.44 to 977. In the first epoch, it's going to a very low value. In the second epoch, it's even one exponential minus plus 3. So it gives us a distribution of all epochs. And in each layer also, in Adam train, the dense 2 layer, kernel 0 layer, bias layer, and every layer, dense layer 2, and so on. Cool. And again, you can like this is currently a step value. You can again make it relative. You can validate. You can use the overlay type to actually see this kind of data. And yeah, mostly that's it. Again, there are some features which you can use in your collab. There are some features which are not available for collab, for which you have to use the Jupyter notebook. In Jupyter also, once you the process still here is same. Once you are till training the model, after that you have to just write this command in your command prompt, and that will open up the tensor board in your own in your port. Let's say if you want to open it at port say if you want to open it at port 6006, which is the default port for TensorBoard, you just have to write this notebook dot display port equal to 6006 and height equal to, you can set the height and width as per you. But yes, that's it mostly. And based on this, you are able to like you know before that also you need to yeah, just from TensorFlow import notebook. So this will open up the notebook in your Z format. Right now, it's this is something which you can use in your Jupyter notebook. So just run this code in your Jupyter notebook, or let's say in your Go command prompt, and you'll be able to open the A in the port 606. Okay. I guess you guys are able to understand what till now, right? Is everyone with me till now? Are you able to understand what I'm trying to say here? Like how this black box can be opened and actually each component can be seen in minute details using TensorBoard? Okay, perfect. Yeah, I'll be sharing this notebook if you want to post this post this session, so you can just refer to it if you need to understand how to integrate TensorBoard in your model. Cool. Coming back to the slides. Yep. Just switch it. Yeah. Okay. Just want the host to actually host the slide window in the screen. Yeah. So, what are the use cases of TensorBoard? As you saw, the first use case which we saw is completely monitoring and deep learning training. We can use the parameters, like let's say we can understand whether we should continue the training process, whether we should stop, and where the issue, as I said at the start, like whether data is the issue, or there are some parameters which are creating problems, and so on. So we can actually understand this training process using TensorBoard. Second thing is in image classification, object detection analysis, we can see we can actually even visualize the images. So when we use larger ImageNet models, like if we use CNN and so on, and or we use RNN for natural language models, we'll be able to understand how and where are the how the inputs are like transforming throughout the model, and it will actually mostly it allows the researchers to explore into the depth of this machine learning model and understand like how we can modify each part. So mostly that's it from my side. In conclusion, you guys know that how TensorBoard is actually useful and how we can actually use it to improve our model, to train our models, and it's always a good. It's just a single line of code, And but that single line of code gives you so much in-depth insight into a model that you will again start thinking, okay, this is how it's happening, and this is how I can change it, and so on. And it's not only TensorFlow; you can also integrate with frameworks like PyTorch and so on to, like, irrespective of any kind of framework you're using, TensorBoard can be integrated anywhere and mostly in any kind of notebook. So yeah, that's it from my side. Thank you, everyone. So, do you guys have any questions?
Cool. That was a nice one, Suryanshu. Thanks a lot.
Thank you.
Just let us check the questions. Then we are up to go. Okay. Uh, Guys, if you have any question, please drop them.
Thanks,
Uh,
Vash. I have shared the link for the collab notebook, so if you guys want, you can just refer to that.
Shreyanshu, I guess your link is not there, not yet there. If you get
Okay,
repost,
just sharing it again.
like
Yeah, can you check it again? Uh,
MS, yeah, the link is I guess available. Yeah,
Perfect.
cool.
Acha, so I'm just sorry. Yeah. So can you just let like show my slide once again? Just one last thing.
Your slides, right?
Yeah, yeah.
Okay. I guess my team will do this one. Anyone from the TFUG who is handling the slides right now? Which slide you want to open, or I just give access to your presentation?
Yeah, it just gives access to my presentation. That would be
Okay,
fine.
you start presenting. They will add you to the studio.
It's already there. Like it's already, yeah. So if you guys want to ask anything or connect with me, these are my social handles. So you can just connect with me on LinkedIn or for Twitter also. It's the same.
Cool.
Cool.
Great. I guess we are getting appreciation for your session, Suryansu, Rupesh, Mohanty, Varsha. Cool. Then I guess with this
Yeah,
we come to the
that's it.
end of today's session. That was a nice one,
Thank you,
Surya.
everyone. Thank you, TFUG, for having me.